Example 3, evaluate the square root of square root of x dx from 0 to 4, or explain why it does not exist. Okay, so square roots. Where do square roots fail? Negative numbers. Do we hit any negative numbers between 0 and 4? No. Square root of 0 equals 0, square root of 4 equals 2, square root of 1 is 1, square root of 1.5 is some number I can't think of off the top of my head. All right, all those things have specific square roots. So we can do this problem. So if I'm going to do this problem, I would prefer to write it in a power structure instead of a radical structure. So we're trying to do an antiderivative here. Power structure has an antiderivative formula. So x to the half is better than the square root of x. And then the antiderivative of x to the half is going to be x to the 3 halves over 3 halves, which is the same as times 2/3. Again, officially plus c for just doing an antiderivative, but since we're doing the fundamental theorem of integral calculus, I can leave the plus c off because it's going to disappear anyway. So 2x to the 3 halves over 3 from 4 to 0 is what we're trying to evaluate. And once I've got it written like this, it simply means to substitute 4 for x, subtract, and then substitute 0 for x. Okay. Usually, if you get a fractional power problem in this section, they pick these friendly numbers that have nice square roots or cube roots, whatever root you're dealing with. All right. Usually, if they do it by hand using your brain, not your calculator. If this said 5 and the square root of 5 shows up, I don't know what the square root of 5 is either. Use a calculator at that point, give me a decimal approximation. But the bottom number is the root, the top number is the power. So if I'm doing the square root of 4, I get 2. 2 cubed is 8. 8 times 2 is 16. I think all of us have the capacity to be able to do that mentally. All right, they're going to pick some number that has a nice even root, or not even, but a nice integer root. So the square root of 4 is 2. 2 to the 3rd power is 8. 8 times 2 is 16. The square root of 0 is 0. Cubed is 0 times 2 is 0 over 3 is 0. That was even easier. So we end up with 16/3 as the answer to the problem. Find the antiderivative, evaluate it at both endpoints, subtract, and that's your answer. Anytime that the function itself has an antiderivative and it is defined for every value on its interval, that's how it works. It works 100% of the time.